Imagine, just for a second, the sheer audacity of trying to engineer a luxury three-room apartment directly into the upper deck of a commercial airliner. I mean, it sounds almost ridiculous, right? The Airbus A380 is already this staggering, highly complex machine. We're talking over 4 million individual components wired together with literally 300 miles of cabling. But taking that incredibly dense space and somehow carving out a 125 square foot flying penthouse, one with a living room, a double bed, and a working shower, pulling that off required overcoming some of the absolute most extraordinary structural, fluid dynamic, and safety challenges in aviation history. Today, we're unpacking the incredible engineering secrets behind the Residence by Etihad. To really understand the stakes of this engineering marvel, we have to look at the financial reality first. Historically, a one-way ticket for this exact experience cost up to $30,000. Now, when a single passenger is dropping that kind of money, the margin for error isn't just low, it's absolute zero. Every single detail, from the exact firmness of the pneumatic cushions down to the precise temperature of the shower water, has to function flawlessly at 40,000 feet. There is zero room for a bad day. Which obviously brings up the core question, how exactly do you engineer a flying apartment? It is this fascinating high-wire act. You have to balance completely effortless passenger luxury on the surface with extreme, hardcore aerospace engineering hidden just behind the composite bulkheads. Okay, let's dive into this and uncover exactly how they actually pulled it off.
Part 1. The ground-to-air transition.
So long before a passenger ever sets foot on the A380, they're moved through this incredibly highly synchronized logistical chain. It literally starts at your front door with an Etihad chauffeur, moves seamlessly through a dedicated fast-track immigration process, straight into a private lounge suite outfitted with custom Peter Marino furniture, and it concludes with a buggy transfer right to seat 1A. It's essentially a massive, high-stakes operational puzzle, and it's entirely designed to make that transition from the ground to the sky feel completely imperceptible to the passenger. Moving on to Part 2, redesigning the upper deck. Making this space a reality took an agonizing 7-year development cycle by the Etihad Design Consortium. During that time, they went through a staggering 400 layout of passenger accommodation revisions, what the industry calls LOPA. Balancing that level of spatial luxury with the totally unforgiving structural realities of an aircraft fuselage is just incredibly difficult. You can't just drop an apartment into a plane. They literally had to rewrite the entire architectural rulebook of the cabin to make sure everything fit, everything balanced, and everything perfectly complied with strict safety mandates. For instance, to make room for this suite and the premium areas next to it, designers had to relocate the traditional forward galleys to create an open reception lounge they called the lobby. But adding heavy premium materials, custom bulkheads, and all those hidden galley mechanisms created a massive structural threat. We're talking about over 2.5 tons of localized weight concentrated directly on a relatively small section of the forward upper deck. And in aviation, concentrating that much mass in one specific area, that is incredibly dangerous for the structural integrity of the airframe. Now, what's really interesting about this slide is how they actually solved that massive weight problem. Standard commercial floor beams are just simply not designed to take that kind of localized punishment, especially when you factor in high-G maneuvers like extreme turbulence or a really hard landing. So engineers had to design specialized load distribution structures. These basically channel those dynamic forces away from individual points on the cabin floor and spread them out evenly across the main carbon fiber reinforced plastic, or CFRP, frames of the fuselage. And it goes further than that. To keep the aircraft's longitudinal center of gravity perfectly stable for aerodynamics, they had to precisely counterbalance the residence. They did this by optimizing the placement of the remaining first-class apartments in a very specific tessellating pattern. Honestly, it's a total masterclass in weight distribution. Which brings us to Part 3, fluid dynamics at altitude. As you probably know, the ultimate enemy of aviation is weight. Liquid water has a density of roughly 1 kilogram per liter. The A380 already burns through about $30,000 of fuel per block hour. So carrying any excess water carries a massive economic penalty. You're basically paying top dollar just to fly hot water across the globe. Because of this, you simply cannot fly with giant heavy storage boilers. The solution? Engineers utilized rapid induction inline water heaters to heat the water instantly, completely on demand. And to give the passenger the sensation of a nice, powerful shower without actually wasting water, they used a pressurized, low-flow delivery mechanism. It aerates the stream, keeping consumption down to a highly efficient 6 to 8 liters per minute. But wait, think about what happens once that water goes down the drain. You can't just let gray water pool in the basin. especially if the aircraft is banking or pitching violently. The cabin inside is pressurized to an equivalent altitude of about 6,000 to 8,000 feet, right? But the atmospheric pressure outside at cruising altitude is extremely low. So engineers brilliantly tapped into this delta P, or pressure differential, to create a vacuum-assisted drain system. It instantly sucks the wastewater away into central holding tanks. It's just an incredibly clever use of the aircraft's natural environment.
Let's look at part 4, containing mid-air emergencies.
Look, luxury cannot compromise survival under any circumstances. Strict aviation rules dictate that a fully loaded A380, which can carry up to 853 passengers, must be completely evacuated within 90 seconds, and they have to be able to do it using only half of the available emergency slides. 90 seconds! When you introduce a complex 3-room suite with solid sliding doors into that equation, the risk of passenger entrapment skyrockets. So to ensure occupants can escape within this incredibly tight 90-second window, the sliding doors in the residence are engineered with mechanical overrides and secondary release latches. This is critical because it allows the cabin crew to physically bypass any electronic locks and slide the doors open from the outside, guaranteeing a clear egress pathway to the main slides.
And this strict safety doctrine totally applies to modern fire hazards too, specifically the sheer terror of lithium-ion batteries. If a passenger's laptop or phone suffers internal damage, the battery can enter thermal runaway. This creates a chain reaction where temperatures can exceed 500 degrees Celsius, that's over 900 degrees Fahrenheit. If that happens in a fully enclosed suite, the rapid toxic off-gassing and smoke accumulation are instantly deadly. To contain this nightmare scenario, the environmental control system was engineered with dedicated air extraction pathways. These continuously pull air out of the suite, completely preventing smoke from migrating to the adjacent cabins. On top of that, those fancy sliding doors and walls, they aren't just there for privacy. They're constructed from advanced phenolic composites. These materials have exceptionally low smoke emission and extremely high flame resistance, so they act as vital physical barriers to contain the intense thermal energy of a fire.
Finally, let's cover part 5, the 2026 economic pivot. So engineering this incredible suite was really only half the battle. The other half is figuring out how to keep it economically viable in the modern era. During the pandemic, A380s were put into deep storage, and their market values just plummeted. Selling them off wasn't an option unless airlines wanted to take massive financial write-offs. So when Etihad eventually brought them back, they had to fundamentally rethink how they sold the residents. Historically, like we mentioned, they relied on a standalone ticket for $20,000 to $30,000, and honestly that often led to the suite flying empty. So the crucial point is their transition to a cash upgrade model for 2026. What they do now is sell the first-class seats at standard premium pricing, and then they offer those already confirmed passengers a flat cash upgrade fee to secure the residence. It's actually a brilliant pivot. It lowers the barrier to entry for affluent travelers, massively drives up occupancy, and ensures this giant structural asset is actually generating auxiliary revenue instead of just taking up space.
And this strategic pivot is exactly why we're seeing a resurgence of this massive aircraft today. For 2026, Etihad has actually scheduled 2,180 A380 departures just from its Abu Dhabi hub. In today's aviation market, major international airports are severely slot constrained. That means you can't just magically add more flights to a busy schedule because the runway space simply doesn't exist. So having a massive 486-seat super jumbo that's packed with maximized premium cabins becomes a highly valuable economic tool and allows the airline to absolutely maximize their revenue on a limited number of daily departures. Ultimately, the design principles established by the residents completely prove that you can successfully segment a commercial cabin into independent residential-style rooms. And that has permanently shifted the entire industry. We're seeing its DNA today in products like Air Francis La Première and ANA's multi-postural The Room. But looking ahead, as airlines increasingly adopt lightweight, 3D-printed titanium and advanced digital polymers, we really have to wonder, if this is what engineers were able to achieve while using heavy wood, metal, and leather on the A380, what mind-bending flying spaces are they going to create when weight is no longer the ultimate enemy? It's a genuinely fascinating question for the future of flight. Thank you so much for joining me for this explainer. I hope you found these aerospace engineering secrets as absolutely fascinating as I do.